Today we're going to be talking about inscribed angles. Our first theorem says that the measure of an inscribed angle, remember that means its vertex is on the circle, so the measure of this angle is equal to half the intercepted arc. So basically that means the measure of angle SAT is equal to 1/2 the measure of the arc that it intersects, which is arc ST. There's a corollary, and we're actually going to be dealing with a bunch of corollaries to this. So we have our first corollary that says if two inscribed angles intercept the same arc, then the angles are congruent. So this blue angle intercepts this arc right here. And the red angle intercepts the same arc. Since both of the measures of those angles are half the measure of that arc, they're going to be equal. So an example involving this, and this could be, some students I think can find this as challenging. What you might want to do is you might want to trace out the angle. That angle intercepts that arc. And similarly, this angle intercepts that same arc. So 3x equals 2x plus 13. So when I solve that, x is going to equal 13. A corollary to this, an angle inscribed in a semicircle is a right angle. Okay, meaning if you have essentially an angle where it intercepts a diameter, we know that diameter there is 180 degrees. We know this angle here intercepts, that angle measure I should say is half the measure of that arc, so that's why this is a 90-degree angle. Okay, solve for x. So we have a diameter, and we have that this angle, angle ABC, is a right angle. So therefore we know the other two angles in this triangle are complementary, so I know that 1/2 x plus 1/3 x plus 5 is equal to 90. When I combine 1/2 and 1/3, I get 5/6 x, and I'm going to subtract the 5 over. Now we multiply by 6 over 5. So we get x to equal 102. Another corollary coming from this. If a quadrilateral is inscribed in a circle, meaning all four vertices are on our circle, then opposite angles are supplementary. Let's think about this. We have this angle right here intercepts that arc. So actually let's put some points down. A, B, C, D. So angle I apologize, I'm naming this wrong. Angle DAB is equal to 1/2 the measure of the intercepted arc, so that's the measure of arc DCB. So angle A is half the measure of this arc here. Now what's the angle that's opposite of that? Angle DCB. So angle DCB, so angle DCB is half that. So that arc there is half the measure of arc DAB. So angle DAB plus angle DCB is equal to half the sum of arcs DCB and DAB. What's DCB plus DAB? Well, that's a whole circle. And we know by the definition of a circle that a circle is 180 degrees, is 360 degrees. So let's have 360, 180. So that's why that one's true. All right, solve for x. So we have a quadrilateral that's inscribed in a circle. So I know that opposite angles of this quadrilateral are going to be supplementary, which means they add up to 180 degrees. All right, so then we have 8x minus 6 equals 180. 8x equals 186. So therefore, x is going to equal 23.25. Okay, our next example. Finding the measures of the arc or angle in circle O, given that CD, so this arc right here is equal to 108, and arc BE is equal to 100. Okay, so let's look at what we got here. We need to find the measure of angle ABC. So angle ABC. Well, they tell me that this is circle O, so therefore AC is a diameter, so therefore ABC is equal to 90 degrees. All right, next, angle CED. So angle CED. Now it's kind of hard for you guys to see, but that intercepts arc CD. So therefore, that's equal to half of that measure. Therefore, angle CED would equal 54. Okay, angle BDE. Okay, so angle BDE, BDE, that intercepts this arc right here, so that's going to be 50. Okay, let me do some quick erasing. All right. CBD. So CBD, again, that intercepts this arc that's 108, so that's half of 108, which is 54. Angle ABD. Okay, angle ABD. Let me highlight that. ABD. So that intercepts this arc right here, arc AD. Well, I know that arc AD plus arc DC equals 180 because ADC is a semicircle. So therefore, if I subtract from 108 from 180, we get 72. So that's what arc AD is, which actually we need to find down here. So let me write that down. But I need to also find this angle. That angle, again, is half that intercepted arc, so that's 36. Okay, next. BCE. BCE. Oh, BCE. I was looking at it the wrong way. BCE. So that's this arc right here. Actually, let me do a little bit of erasing so we can see a little bit. BCE, well, that intercepts arc BE. So that's half of the measure of that arc, so that's equal to 50. We already found AD. Lastly, we have to find the measure of arc ABC. So arc ABC, since AC is the diameter, the measure of that arc is 180 degrees. Okay, chord-tangent angle theorem. So what this means is the measure of an angle formed by a chord and a tangent is equal to half the measure of the intercepted arc. So if you have a chord and a tangent, therefore that chord and that tangent, the measure of that angle, like angle 2 is that big angle, is half the measure of the intercepted arc. And angle 1 is going to be half the measure of the intercepted arc. So therefore those equations would be angle 1 is going to be half the measure of arc AB, and angle 2 is half ACB. Okay, so QR is tangent to the circle, and find the measure of QRS. So this angle here's measure is equal to half the measure of this intercepted arc. So therefore the measure of angle QRS is equal to half the intercepted arc. So that's the measure of arc RPS. So QRS is 5x minus 10. That equals 1/2 of 8x plus 32. All right, I'm going to go through and distribute the 1/2, so that's 4x plus 16. I'm going to subtract the 4x over to get an x, add the 10 over to get a 26. Now realize that's what x equals. I need to find the measure of QRS. So I need to plug 26 back in to 5 times 26 minus 10, and we get 120. There are your 3 lesson questions. Please make sure those are submitted on time.